lecture, we have learned about the measurement uncertainty. This is the presentation of the measurement uncertainty. For example, the concentration of the lead is 61 plus or minus 20 milligram per kilogram. Where the uncertainty is an expanded uncertainty using the coverage factor of 2. The coverage factor of 2, it is due to the normal distribution. And when we read the t-table, that means within 2 standard deviation in a normal distribution, it will give you around 95% of confidence. That means between 41 to 81 in that range. You have confidence, 95% confidence that the true value should be lying between this range. Okay. And then we will have a lot of information, how to define the measurement uncertainty and the procedure. It is the information with the reference. I also put this, the RAM, which is a free download document, and post into the PU Moodle. If you want to take a look, you can download and read it. Okay. And then we learned about the normal distribution. That this is very important because when we expanded our combined uncertainty, we normally will use the coverage factor of 2, which is around covering 95% in this range, 95% of the populations. Okay. And we also learned a term that it is the experimental standard deviation of the mean. By repeating several experiments, and we will know that there is a standard deviation that can be calculated from several trials. And also the number of the trials we put is the n. And then we can calculate the experimental standard deviation of the mean, which is the precision standard uncertainty. When you present the answer to your client or to your boss, you get the average, it is the mean, with the t factor. The t factor you normally consider is covering 95% of confidence and how many trials you conducted. And you will have your general range of the mean is the result. With that general uncertainty, you have 95% confidence. And when considering that some experimentals or the data, uncertainty data, that cannot be covered by repeating, you may consider the distribution could be rectangular. Okay. Root 3 will be the factor will lead to the calculations. Or maybe the distribution of that standard uncertainty distribution will be in the triangular mode. Root 6 will be the factor for your calculations. There are another factors, but may not be used in our chemical analysis. This is the standard we are reference to calculate the measurement uncertainty and how to express this MU in our calculations. There are 2 terms very important. The type 8 standard uncertainty is the small letter u. It is by the statistical analysis of a series of observations. That means your experiments can be repeated several times to measure one samples. The variation due to the position, you can calculate the position standard uncertainty. For others, other than that, those observations may go to the type B, standard uncertainty. The data, normally you are referenced to the manufacturer's specification. For example, is the volumetric files or the purity of the chemical standard. You need to reference to the manufacturer's information, how it is distributed, is the rectangular or triangular or normal distribution. Those factors are told by the manufacturers, or the information is from the certificate. After you get those information, you will use your calculation and combine them. You will have the standard combined measurement uncertainty if you have a several measurements. And then in the final step, you need to calculate it. It is the expanded uncertainty. Now it's capital letter U. The K factor, normally we will use the K equals to 2. And then we are approximately have the confidence 95% that the result with the 95% coverage factor K equal to 2 in that range. The true value should be in that range. Okay. I also give you some information about the clear path or the clear field, considering the uncertainty if it is the limit, the regulatory limit. It is a clear field, even the uncertainty is considered. It is a clear path, even the uncertainty is considered. For the scenario 2 or 3, because the result may touch the regulatory limit, or this one may touch the regulatory limit. That means the results, those results, we may consider inconclusive. Whether how to report those results, we need to communicate with our clients and see whether they have a resolution, and then we will report after we come up with the solutions with our clients. Otherwise, we will say inconclusive. Although you have the past result, but you still have some possibility that you will get failed. Okay. And here's the standard uncertainty for each of the measurement parameters. You have the small capital letter U, a small letter U, and then you use the square to sum up them. As I told you before, because some of the apparatus may be calculating in a milligram or in the volume in the cm cube. So those are units cannot be simply add them together. We will change them into the percentage. So we can combine them by using this calculation equation, the formula. You will get the combined standard uncertainty. Change this to the expanded standard, to the expanded measurement uncertainty. You will need to add the K factor. The common K factor, most of the chemists will use is 2. For the K factors too, we always have the 95% of confidence. If you choose the K factor 3, you have more confidence, yes, but the range will be quite large, okay? It will be very easy to touch the regulatory limit, okay? Okay, let's come back to our today's lecture. In today's lecture, we will talk about the quality assurance and quality control in these 2 hours. Please let me know if you cannot hear my voice, okay? Text me. Quality assurance. The quality assurance is a general, very important procedure or the section in analytical laboratories to ensure what? The result is correct. To ensure the result is correct, okay? Normally there is a manager writing a pen. It is the quality control pen, and he can also, or your subordinates or the technicians or the chemists to conduct the analysis have the raw data, and the calculation, maybe use the computer for your calculation or use the write down in your worksheet to do some simple subtraction calculation is also fine. And then the quality manager need to check the result as well as the quality control samples. Several quality control samples will be analyzed, and then the plan, that means every day the plan is the same. You have the plan and submit the quality control samples alongside with your testing samples. If the quality control samples can pass the preset requirements, you expect all the samples result would be corrected. Okay, it is simply quality control systems. It is the organization of the quality assurance setup in the laboratories. How can we ensure that the reliable and good result? Of course, you have the quality control systems, but under this quality control system, what are the main factors? Okay, or what inside this QC or QA systems? We also have the reference materials. The reference materials is just like the ruler. You use the ruler to measure the distance, how long of the dimension, right? If your ruler is accurate, your measurement result would be accurate. The reference material in chemicals now we use in the laboratory could be the concentration we prepared. Okay, the concentration of the chemicals we prepared. When we bought the chemicals from the manufacturer, you may ask for the certificate for this reference material. It will give you the information, for example, 1000 ppm, plus or minus 1.2 ppm. The uncertainty is 1.2 ppm. The reference material concentration is 1000 ppm. So when you use this stock solution to make another intermediate solutions, and then you prepare the calibration solutions, should be in a very high accuracy, okay? Just like you make a ruler, but this time you use the solutions to make the calibration curve. Then you will use the calibration curve for measurement the samples. Maybe due to the response, maybe due to the M over C, the mass, the response, and you can reach the concentrations. And also the QC/QA system, you will compare with the laboratory comparisons. We may talk in the last lecture. The inter-laboratory comparison is just like the public examinations for the laboratories. Okay, compare their result. And the QC and QA systems also must include the method validation. The method validation, as you learned before, should have the MDL, IDL, calibration curve recovery, bias study, or even the precision, or the selectivity of the method, robustness, something like that. You know how your method performs. How it performs, is it well? By using the method validation data, you will note how well you can perform this method. Okay, by using those data, you can abstract the information to do the measurement uncertainty calculation. So after you have the method validation, you have the uncertainty measurement and calculation. Traceability. Traceability, this term in our QC QA system is not only it's a paper we call the traceability. I know what the samples is in this worksheet. Not only this, when it received, we have the receive date, we have the test performance date, or the report issue date. The result, I know who conducted the test, who, maybe the supervisor, who is that check it and countersign this result. And for your laboratory manager to sign this data in the report is correct. It's not only for those we call it traceability of who do that, when do that, where do that, okay? Which instrument you are using, not just like this. It's for the traceability to the SI unit. Okay, SI unit. The SI unit for the chemical analysis, of course, is the mole. When the mole divided by the volume, you will have molarity, and you can always change back to the concentration. Okay, traceability. After doing all those, you will ensure the reliable and equal result. Here are two simple definitions. How to differentiate the quality assurance. Assurance involves the overall measures taken by laboratory to regulate the quality. This one is a big definition, and QC would be a subset of the QA. The quality control relates to the individual measurement of the samples. There may be a lot of QC scenarios, and those QC scenarios all are under this quality assurance systems. The ultimate goal, of course, is to ensure the laboratory can run the method correctly to deliver the reliable analytical result. Here's the definition, and you can read by yourself. It is simply is the workflow maybe you have encountered in the last lecture. After sampling, and then you break down the samples into small pieces, and there may be a lot of the analytical method for the extraction. You use the solvent extraction, use the time, or use some destructive method, use the access to break down all of the organic matrix and extract all of the heavy metals. Two types of the different methods, and input to an instruments for determine the concentration of the target analyte you want to know. Each procedure, each steps may encounter and add the QC. The QC should be controlled for those errors is prone to be happened. Okay. Here's also some reference for the QA documents, ISO standard. You need to purchase this one. You may look for it in the through the internet. Okay, ISO standard. You need to pay for it. To ensure the quality for the result, of course, you have the good personnel. Good personnel, that means the person should be well trained and have the knowledge background of this analytical method and have the experience to do that. And also in the future, they will repeating with some refreshments of this personnel to ensure he can do or she can do the right thing. The traceability, as I told you before, is the chemicals maybe. The traceability to the SI unit, the concentration of the chemicals, or when you measure the sample weight, the balance should be calibrated to ensure the weight is correct. Okay, it's the traceability. And also the method validation. Method validation you may learn in this lecture, in previous lecture of this course, to ensure that the laboratory can conduct this method for the analyze correctly. And the person, such as the chemist or the technician, know how to perform this test. And then those data collected in the method validation, you can use to calculate the uncertainty. For the routine analysis of the method, just this, you have this data traceability personnel is insufficient. You need to add some QC procedures. Normally we call it the in-progress control or inline QC. That means the analysis should be in associated with the sample analysis in parallel. Okay. It is a programmed control plan. Programmed control plan, that means it's presetted in the method as standard operation procedure should be include the QC plan, and each analysis maybe in batch. For each batch, the QC analysis should be the same, should be carried out with your samples, okay, in parallel. Sometimes we may have the internal audit. Internal audit, that means you invite the knowledge people inside your laboratory, but it is not exactly doing the same thing. Maybe you are invited organic analytical manager to conduct the analysis for the inorganic analysis. You invite another person, not in the team, but in the same company, to conduct the audit. Audit is to oversee you are conducting the same standard operation procedure in the laboratory, and to see whether you are compile with the procedure, follow the procedure, or the apparatus, the instruments, or how you calculate the result is according to the procedure you are written. External audit. External audit, such as coming from the accredited organization in Hong Kong, for example, the Hawkers, okay? In China, the Sinus, okay? In the UK, UCAS. They send out their expertise experts and go to your laboratories to see what you are doing to conduct this analysis. Are you following the standard operation procedure and can deliver the reliable result? They will see the SOP and also in parallel and compare with the standard operation, the standards published by the ISO or the country regulations to see where you are compiling those regulations. Because they are not within your laboratories, those are external audit. And the people sent to you is the external auditor. The personnel, to ensure you can have the quality assurance, you ensure they have at least some of the chemical academic backgrounds with the qualification. Do they have received any training? And you may have to prepare the training records to tell the assessor or to the auditor that the person is trained. They know how to conduct this analysis. And then the effective of the training. After the training, yes, I told you this is how to calculate the measurement uncertainty. The effectiveness should be evaluated by, for example, the examination, or you give the sample to that so-called trained person to see whether he can give you the result as you expected, okay? And also, you need to give him or her the continuous competence assessments. After 2 years, maybe she will have or he will have some idea, she modified the test procedure. If then, you need to revise the SOP. Otherwise, you are not following the SOP and you may give another wrong result. Traceability. Traceability for the instrument, we need to use the calibration procedure to ensure the instrument is working properly. Okay. In Hong Kong, we also refer to the HAWKES guideline. This one is the HAWKES supplementary criteria 2. Okay. To tell you how to calibrate your instruments. First, the instrument should be calibrated and then you can use it. Before you calibrate it, you cannot use it. Okay. When you calibrate it, you should have a calibration report to tell the auditor or your client it performs well. Okay, it will give you the correct result. Besides, you need to keep the adequate maintenance. For example, you ask for the engineer to check it or replace some important parts for it. I give you some slides, the PDF. It is the supplementary criteria. For example, a balance, you will always use to measure the weight of your samples, or to prepare the calibration curve, you measure the chemicals in the powder form and use the solvent to dissolve the powder and make the calibration curve in the volumetric phase. Okay. For the balance, for example, the calibration for every 3 years should be calibrated according to this international standard. For verifying the balance for each measurement, you need to zero check. That means you need to tear the zero. before daily use, you need to one-point check a known mass to ensure the balance is working properly. What else? Every 6 months, you need to check it whether the balance repeatability is correct. Okay, it is the Hawkes supplementary criteria 2. For the instruments calibration. For the house reference material, yes, we buy the reference material in a high accuracy. That means you buy a very expensive ruler for your measurements, just like that. Okay. Very high purity, we call it the reference material or certified reference material. If you don't have it, most of the time, the laboratory will require you to buy 2 batches. 2 batches, that means it is come from maybe 2 sources. If it's not the certified reference material, you need to purchase from 2 manufacturers. If only one manufacturer can produce these chemicals, you buy different batches. The batches produced 3 years ago and compare the batch produced this year and to see the concentration is agreed. Okay. We can see this supplementary criteria 1. Sorry, not this one. Supplementary criteria 1. How to use this chemical reference material and the commercial chemicals for the calibration of the equipment or to prepare the calibration curve. Okay. For the quality assurance, some of the routine analysis of the samples, you need to have the sample storage conditions should be met with the testing procedure. Maybe it is stated in the standard, the international standard. And the subsampling procedure, monitoring of the environmental conditions in the laboratory should not be too hot or too dry. Okay, the temperature, humidity have to control. Verification of the critical consumables, because maybe some of the tests we need the cleanup. Okay, the cleanup, maybe we use the SPE, solid phase extraction tubes. Okay, the size of the extraction tubes should not be too small, otherwise it will be overload with the high amount input of the samples. Okay, and then it is the critical consumables you need to know. The sample size and your SPE size should be matched. Okay, it is critical. Whether this SPE can trap your target analyte, of course, you need to check through the method validation, or even after the method validation, you purchase from the manufacturer. Today, I receive a batch of the SPE. You need to check before use. Maybe the problem is not due to your method. It's due to the problem of the SPE you received today. Okay. Measure and ensure the performance of the critical parameters. That means what is the critical parameters may introduce a lot of uncertainty. Those steps should be critical steps. In the laboratory, you will not just paper and then include all the information and it's on the white paper. You should have the form. The form approved by the laboratory will be the worksheet. What inside this worksheet and signed by technicians, approved by supervisor would be the record. Okay. And also you need to know how to reporting the significant figures for the calculation, especially for the calculation. Review of the critical methods performance characteristics. For example, after you use the GC for a very long time and you see the baseline is moving up, and then you use a small concentration injection into that instruments, and you cannot read any peak. That means the column may be contaminated, need to clean up. Talk about the environmental conditions. We need to follow the requirements as the standard method set. For example, for the textile analysis, when you receive the samples, you may need to conditioning to do some conditioning. The conditioning is the room. You have the standard humidity and the temperature, and you put it into, for example, 1 day according to the standard. The standard is the procedure written by the country or international standard. After you put it into this room for X hours, and then you can use these samples further for the analysis to proceed your analysis. Okay. So the environmental conditions is important. And there will be the temperature affecting the volumetric preparation. If your temperature in the laboratory is too high and your glassware is not good for the measurement, there may be some of the effect to your result. Humidity. The humidity, if you are not controlled, but you want to measure the moisture correctly, it will be difficult. Okay. And set the environmental conditions of testing area for the critical steps is also important. So in accredited ISO IEC 17025 laboratories, normally we need to control the humidity and also the temperature within the laboratories, especially for the balance room. Okay, balance room. Because balance room, you take the reading of the weight of the samples. The temperature will affect the performance of the balance. Okay. We also need to monitor the conditions. Continuous thermal hydrometers, cyclometers, thermometers to record and keep daily record. For example, you use the refrigerator to keep your samples. It's the food for the frozen food. Okay. The frozen food, you need to monitor the performance of the refrigerator. After you left the laboratories overnight and then come back, there's some time, maybe there's no technicians or the chemists inside the room. If there is the electricity fault and cause the temperature increase, and you will have the deterioration of the food samples and cause some variations. So if you keep the record all time daily, you will know whether there is some fault in the refrigerator at night when no people is there. Next, sample storage, I think, okay, is the very similar to the temperature control. The storage area, temperature, the fridge temperature, humidity may affect the performance, especially for the moisture determination. Keep the daily record to ensure there's no change. And how to preserve the method. This one is very tricky. For the environmental test, the samples you collect from the environment, if you want to test for the heavy metals, normally we will stabilize the samples with some acid. You add some of the nitric acid inside your sampling bottle to preserve it. For the cyanide, cyanide cannot touch with any acid. The cyanide, when you add with acid, it will give the toxic HCN gas, okay? Cyanide gas, halogen cyanide gas. So to preserve the cyanide, you will need to use some hydroxide base, okay? Sufficient space to prevent contaminations. That means in your laboratory, I know in some commercial laboratory, maybe there are a lot of samples, but you need to separate here one sample to another sample, especially the bottle, the sampling bottle is opened. Otherwise, you will mix up or cause some contamination problems. Verification of the critical consumables. Very simple chemicals. The dilutions is water, okay? The water, even the water have different grades. I will give you some examples. This one. For example, this is the ISO standard for the water. Water in this standard divide into 1, 2, 3 grades. Okay. For those people may are working in the toys laboratory, may encounter this standard. The very simple, the lowest grade is the grade 3. Okay. You have checked the pH, you have checked the conductivity, oxidizing matters inside the water, and also whether it can absorb 254 nanometers residues. This pH is the acid base of the water. Okay, don't want to affecting the chemicals or the samples. Electrical conductivity, when pure water is adding with certain salt with the positive ion or negative ion, it will cause the conductivity increase, right? If it is pure water, should be less or minimal amount of the ions, ION. So in the lowest grade, conductivity 0.5, grade 1, 0.1. Okay, oxidizing power, maybe some oxygen is dissolved in it, so it will have the factor to measure. Absorbance of 254 nanometers. Normally, those are the aromatic substance. Okay, aromatic substance. For the highly pure grade 1, should be none, almost none there. Residues, of course, is talking about the water containing any residues. Dissolved ions should be very small. And the silica is the common contaminants in the environmental, from the environment to the water. Okay, grade 1, 2, 3. If it is 3, you need to do a number of tests to tell the assessor, to tell the auditor, you are using the grade 3. Okay. For the higher grade, more stringent report, the data should be given after you analyze the water. Otherwise, you cannot use those waters for your chemical analysis. Okay. For the grade 1, should be ultra high purity of the water. Even you open it for 1 or 2 minutes, it will deteriorate into D2 due to the environment contamination. Okay. Water exits used for dissection or the material, you have the analytical grade. If you do the inorganic analysis, you will also have the trace metal grade, ultra trace metal grade. Trace metal grades may contain some of the heavy metals in ppb level. Okay. Ultra trace metal grade, you are measuring very low concentration of the heavy metals, maybe in the sub ppb or ppt levels. If your exit already containing very low levels, it will make the baseline higher and your signals will not be good for you to interpret it, the result. Okay. The cartridge such as the SPE I told you before, the solid phase extraction cartridge, you need to know the maximum capacity, how much such 5 grams of the SPE can do the experiment. Okay, 1 gram sample, 10 gram sample, or 5 gram samples. Always have a maximum capacity for the 5 gram cartridge. Okay, if you cannot hold those, use 5 gram, you can expand it into 10 gram. Okay, potence of the M site. Some of the food analysis may use the M site, for example, the dietary fiber analysis. How do you ensure that the M site are still active? Compare the expiry date. Yes, it must be compiled. But when the M site deteriorated, you need to do some quality control and to check the M site is still working. Potency of the reducing oxidizing agents. Some steps maybe need to have the reducing agent or the oxidizing agent added. Also, those reducing agent or oxidizing agent is very active and easily be reduced back or oxidized back. Their efficiency may be deteriorate across the time. Divatization agents for the GC analysis, because the hydrogen bonding of the amine or the OH bond or the acid group inside the column, you need to protect those OH bonding, hydrogen bonding. You will use divatization reagents, add the cyanide group there, and you will give the sharp peak. Okay. The divatization reagent react with water. The air has water and also will deteriorate it across the time. Characteristic of the solvent or reagent density storage condition. See next slide. Okay. Procedure and the criteria for checks of the documents established based on the intended use. You need to follow the procedure and any manufacturing procedure, how to use this chemical apparatus as well. Okay, the quality, this one that I showed you before is the grade 1, grade 2, grade 3 water. Several tests should be conducted before those waters can be used. Okay, this one is the same, repeated. This is the definition, repeat, and I'm sure you can read it by yourself. Some of the terms may be encountered in the QC, quality control. Laboratory checks samples. Laboratory check samples should be put into a suitable container. Some container should be airtight or should be avoided from the light, okay, or not easy to break to protect your LCS. That LCS, laboratory check samples, you will put into your analytical sequence and analyze it as and in parallel with your sample batch. Okay, the LCS, you know the concentration or the result of this LCS. You keep it because you know you repeat for a number of times. You know the answer. You know the answer is stable. After you use this sample, you know the result. Okay, the result, of course, is not 0. Okay, you keep it in a proper storage condition. That means the temperature, humidity should be kept. And also you know how long it will be stable. You need to verify it. And cross-check with the old or the standard repeated standard solutions. That means your previous batch and the new batch. You can use the LCS to check whether your preparation of the calibration curve last week and next month is the same. Is it reliable correctly? Because you know this answer. Old calibration curve, new calibration curve, you prepare, and the result is the same. That means your calibration curve should be correct and comparable. Okay. You also need to label this LCS for your calibration whenever the verification status is applicable. Verification before preference. You can account with the CRM. CRM is the certified reference material. The chemicals or the matrix containing analyte material you purchase. You check it out because the CRM are internationally agreed the result, because the production of the CRM should be the highly sophisticated. In other laboratories, we call it the CRM provider. Okay, the CRM provider should have a more stringent requirement than those ISO IEC 17025. So the result of the CRM should be very accurate, and their measurement uncertainty for their result should be very, very small. Okay. When there is no CRM, in the market, for example, the lead in the pork, okay, we don't have this lead in the pork CRM because the matrix is not easy. If I have the lead in the pork, I don't have the lead in the beef. Maybe we don't have the lead in the vegetables CRM. It is a matrix CRM, not easy to make. Okay, so you need to verify against the reference material only without the matrix, or use different brands to verify whether you can obtain the reliable result. Okay, it's the same as I talked before. If it is only manufacturer can produce this CRM or the chemicals, you need to check whether they are in a different batch or the different log, they are also agree with the concentration as the certificate or the concentration they claimed when you received it. Stability check. You check the chemicals you bought should be stable for the CRM, like our canned food. Normally, we'll have the expiry date, okay? Before the expiry date, the quality can be obtained. Otherwise, it cannot be used anymore. Sometimes the CRM or the RM certificate can be extended. For example, it says it's 5 years. And after the 5 years, you check from the internet, maybe stability is still good, they will extend more time. You need to check with the manufacturer. Those CRM, LCS, and the stock intermediate and the working solution should be clearly labeled. Okay, should be clearly labeled, so you can trace whether this chemical label is from which intermediate stock and the intermediate stock from which original stock. And the original stock can trace back to which bottle of the chemical you bought. Okay, a chain, a broken chain, you can trace back, and who made it, when it is made. Is it expired? You need to label it very clearly. Performance of the critical parameters. What are the critical parameters you need to check? For example, you use 1 gram of the samples and extract with 10 ml of the solvent. It will give you the extraction efficiency issue, okay? 1 gram, 10 ml. How about I use 1 gram, 1 ml of the solvent? The extraction efficiency normally will not be good, okay? Because the solvent cannot touch all of the samples. How about I use 1 gram and 50 ml? The mixing or the extraction may be good, but it depends on your container. Okay, when you decide a new method, you need to consider the extraction efficiency. 1 gram in 1 ml, normally we will not consider it. It is a good suggestion for you to conduct the trial. Okay, here we go, and another term of the surrogate. The surrogate is the chemical that you have the similar chemical structure of your analyte. Very similar. They're just like the brothers or sisters. Okay, very similar structures. If you add this surrogate into the sample, in your real sample for analyze, if you get back the surrogate, recovery is good. You have confidence your target analyte can be extracted at the same time. Okay. Surrogate. What's the difference of the surrogate and the internal standard? The surrogate and the internal standard are also, we are relied on the similar structures, right? But the internal standard, we will use the internal standard for calculation of the result. For the surrogate, normally we will just say it is a surrogate similar structures. And to ensure your extraction efficiency is correct or reliable, you can extract something just your target analyte. Matrix effect. Matrix effect should be very complicated, especially for the environmental samples, for the food samples, because there are different types of the food samples in the world. The matrix will affect your extraction efficiency sometimes, or enhance your extraction efficiency sometimes. We don't know. So when we conduct method validation, we need to learn about the method, the matrix effect, okay? And then the recovery can tell. We cannot conduct the method validation use the pure water because the pure water don't have the matrix effect. And then your method is applied to very complicated matrix. For example, the meat, biscuits, high-fat cheese, chocolate, okay? So when you conduct the method validation, you cannot choose the simple matrix and apply to those complicated matrix. The matrix effect may mask your target analyte extraction, okay? And cause the low precision, low recovery. And your result may be underestimated. Interference of the internal standard. The internal standard, as I told you before, is to calculate the result. And the internal standard normally is at in the beginning, before the extraction. And you need to analyze the IS internal standard at the end of your instruments alongside with your target analyte. The ratio should be kept the same. Even there is a loss of target analyte, the ratio from the beginning to the end should be corrected by those internal standards. Okay. The internal standard, in the later we will learn how to use the MRM to do so. The intensity of the internal standard of samples also important. If you lose all of the internal standard, that means your extraction is failure, and you need to consider another extraction, or the extraction, the result cannot be reported. Okay. Let us have the 10 minutes break. I will come back at 8:13. Okay, let's come back to our second part of this lecture. Let me know if you cannot hear me, okay? Let me know if you cannot hear me clearly. Okay, we move on. It's a record, very simple. The record should have the full description of the items to be tested, and you need identification of sample numbers. You will not have two identical numbers for two samples, okay? The method of testing procedure, you have to edit into your test report to indicate what test method you are using. Sometimes you are required to use the critical equipment. The critical equipment, reference material, and the standard solution should be used for the very highly sophisticated, complicated testing method with high accuracy. Because the instruments should have their sensitivity difference, okay? The high price of the equipment should have a good sensitivity and will give you a very, very low concentration of the detection of the target analyte. When we read the equipment, normally we will know the detection limit, how low a laboratory can report. Original observations, just like you are writing something on the paper, but you want to correct it, you cannot cover the original observations. You need to cross it out and have a signature with the date. And sometimes you need to write down the reasons. For example, it's the typo or the calculation error. And then to let the original observations still in the record. Identification of presence and the date of the performing and checking the works. That means who do that. And then ask the person to write down their name. And in case we need to check, we know who do the test and ask for extra information may or may not cause the problem of this test and give the valid result to your clients. Within this one, you can read it by yourself. It's a talk about the records, okay? The most important, that is the brand paper, is not allowed by the Cochrane. That means all of the record sheet should be a worksheet that should be approved by the laboratory before you use. You cannot use the brand paper to record all the result and write down the sample name, sample unit code, okay? Should be approved before use. So when doing the Hawkins assessments, the worksheet should be approved documents, have the template. You cannot change every day when you're doing the analysis, okay? Newspaper or tissue paper, of course, you cannot be used. Now talking about the rounding numbers. It's very simple rounding rules, okay? Just give you this to see whether you learned or not learned before. This one, at least significant figures more than 5 easily. You will have the rounding up, okay? But if it is the last figure is 5, or we can say 5 and other number should be 0, which is the nearest is the odd number, round to the descending figure up this way. 5, this is should be 50, okay? 50000. Because it's the odd number, so round up. If this one is 5, 50000, okay? Because it is an even number an even number, no roundup. Okay. More example. So whether I have the more example. Those are rounding rules are accepted by internationally. Okay. When the last digit is 5, round up or round down will depend on the descending, the in front digit, even or odd. Give you example, okay? 3 decimal place. 3 decimal place here. 1 decimal place, 2 decimal place, 3 decimal place. This one is 4. So round to 5. Okay? No round up here. This one, 55001. Because it's a 5, not all 0. 5 should be rounded up. 2846. Okay. How about all the remaining is 0? Remaining is 0. The previous one is even number. No roundup. Goes back is 0. It is the odd number. Roundup. Okay. That's the information I give you in this slide. Equipment qualification. Also, when the equipment you use, you need to know the sensitivity, that how low of the analyte the instrument have a response signal. The response signal should have the signal to noise ratio at least 3 times to the signal to noise ratio in comparison to the noise, right? Calibration of the balance, steady check, repeated check. I show you the supplementary criteria 02. Calibration not only for the balance, also for the equipments. You also need to use the CRM non-concentration to see whether the instruments can give the response. Very simple. How to preparing the calibration curve. The calibration curve, you prepare the 0.1, 0.2, 0.3, 0.4, 0.5 even. You give the calibration curve standards. In a very perfect preparation, you will have the straight line, right? Calibration curve is a straight line and have the R square equal to 1 if you prepare the good calibration curve. Okay. Give you some terms you need to remember. ICV, initial calibration verification standard. After you prepare the calibration curve, the ICV is the middle concentration of the calibration curve. Normally, it is come from or prepared from another brand of the chemical source. Okay. Continue calibration verification standard. Normally, after you prepare the calibration curve, and then you are immediately will inject this ICV. And after several analytical analysis of the samples or the QC samples, you will have the CCV to bracket the samples and the QC samples. The quality control standard samples, we call the QCS, okay? Quality control standard samples. The blank, method blank, that means you are go through all of the extraction procedure, but without the samples. You are watching what? Any contamination of the solvent, any contamination of the procedure you are using, and add the target analyte into your extraction procedure, testing procedure, okay? Instrument blank. Instrument blank normally is the solvent. The solvent, if the pure solvent give you the signal, maybe the solvent don't have the problem. Either the solvent have problem or the instrument containing some residues in previous from the previous analysis. Okay. For example, the overload, very high concentration in the previous injection, 1000 ppm. Okay. And your next analyze still have some of target analyte. Maybe it is contaminated in the tubes, okay, or inside the column, or even in GC is the liner, and cause the false positive of the result. Calibration blank normally is the solvent now are used to prepare the calibration standards to check whether the standard contaminated with the chemicals. Especially very important is for the phthalate analysis. Phthalate is the plastic additives. For your buying the solvents, hexane, tetrahydrofluorine may contain the plastic parts. Maybe it also contain or contaminated with the phthalates. You need to check. Laboratory control samples. Those samples have been purchased in the laboratory for and used for the analysis for a very long time. You use these laboratory control samples to be tested alongside with your real samples analysis. If the LCS give the result is like the previous in the history, the result, that means your samples is highly reliable. CRM is chemicals you purchase from the manufacturer with the certificate. And then, see whether any problem. We'll handle later. The CRM purchased from the manufacturer with the certificate may have the concentration is in very high accuracy, okay? Very low or small measurement uncertainty. Try to see whether you can repeat the result. Matrix spike. This word means you are adding some of the target analyte for your analysis and to see whether you can get it back. With the matrix, that means the matrix effect should be minimized. Okay? Matrix spike duplicates, you repeat 2 times for the matrix spike samples, 2 times. Samples replicate for the duplicates, you check the precision of analytical procedure. Let's see the analytical procedure. For example, you are preparing the calibration curve and conduct the analysis for the total digestion of the lead. Okay. Normally, the sequence will be like this. Analytical sequence, you inject the calibration blank. That means the solvent. You are preparing the standards 1, 2, 3, 4, 5. Okay. You are purchase the chemicals from first source. That means the brand A. Okay. For example, the brand A. You prepare the calibration curve. And then you inject the ICV. Still remember the ICV is the injection of the middle concentration of the calibration curve. Normally you prepare in the second source is standard. If this calibration curve, the chemical in the first source standard is deteriorated, contaminated, or even you make the wrong calculation and then the calculation the concentration is incorrect. If you use back this standard 3 and put it here as your ICV, what will the problem? The problem is because they are always prepared from the first source standard, they always agree. If you prepare the calibration curve in one source, you prepare the ICV, the concentration as standard 3. If you are measuring the wrong weight and prepare the stock solution, you can check it from the second source. Okay? And then you have the method bank. Method bank is the QC samples. You need to add always. And also you need to analyze the LCS CRM samples as your QC samples. They give you a positive known concentration of the target analyte. This one should be negative. This one should be positive, and you have the known number. And you analyze 1 to 20 samples. 1 to 20 samples, we always call it a batch. Okay. This one is the first batch. 20 samples forms a batch. And you add the duplicate one of the samples. For example, here is 20 samples. You select the 10th samples and do it again. It will be duplicate to see the position of your analysis. Spike samples, you select, for example, the 10th of the samples. You add the known concentration at the middle concentration to see whether the target analyte can get such increments, okay? And to check whether the matrix effect is insignificant in that matrix. After that, you have the CCV samples. CCV samples, ICV samples should be prepared in the second source standard, okay? Those form a complete batch analysis. If the QC sample pass, negative, positive, this have the precision, for example, 10% precision. With the compare result, spike have the recovery reasonable, and this QC pass. That means, for example, this one is 3 ppm, your CCV is 2.9 ppm or 3 ppm, should be passed. And if so, this dose 1 to 20 samples, the result can be released. Those are the QC checks. After the QC pass, the result can be released. And then you will repeat the method bank and the LCS and also different samples in the same manner. Analyze the second batch, okay? The second batch. And then analyze the QC repeatedly, method bank, LCS, duplicate, spike. Finally, it's branched by the CCV. If the dose result, the QC result are correct, your result can be released. Okay. In the Hopkins requirements, normally when you prepare the calibration curve, if it is not indicated in the standard, only 3 standards, that means 3 points to form the calibration curve is sufficient. Okay. No need to prepare 5 points. Okay, because when 3 points, you can make a straight line. It's not a triangle, should be linear. Okay, for the second day, maybe we want to use back this calibration curve. We just use the CCV to check back the QC and bracket those samples. And you can continue to use this calibration curve for your measurement. Okay, for the day two, if you don't want to inject this standard again, calibration curve again, we check it to ensure the instrument can work properly. Your method blank, CRM, duplicate, spike, also correct. You can continue your analysis. Here show you the QC requirements, which is indicated by the HOCUS supplementary criteria. For example, is the 20. 20 is for the chemical testing analysis. For example, the toys, pharmaceutical products, chemical testings. Blank. When you analyze the method blank, 1 per 20 samples. That's why I told you 20 samples normally will form a batch. Okay. Laboratory control samples. The laboratory control samples also 1 per 20 samples. You need to analyze 1. Okay. Spike. You add the known concentration to one of the samples every 20 samples. Duplicate also every 20 samples. Okay. With the sequence, every 20 samples, you need to have a method blank. Duplicate here like this. Okay, and then repeat it, and repeat it again and again. This is the guideline. It's also the original of the reference why we consider 20 samples is a batch and we need the QC, okay, to ensure the result is correct. If I have very good at QC and want to do more, 1 per 10 samples, is it possible? Is it allowed? Because QC is to check the stability of the instruments as well as the performance of how the laboratory can perform the analytical methods. If you say 10 samples, I add the QC, of course, more frequent, welcomed. How about if I have only 19 samples? I cannot meet 20. So can I skip the QC samples? No. If you have only 19 samples, you still form a batch, okay? If more than 20 samples, I have 21 samples, you should have 2 batch and then 2 sets of the QC samples. If you have the 19 samples, it forms 1 batch. You still need to do method blank, LCS, duplicate, spike, and those CCV. Okay. If you have the 21 samples, it will fall into another batch. Those QC should be due again. Okay. 20 samples for a batch. Less than 20 still need to do the QC. More than 20, that means at least 2 sets of the QC samples should be conducted. That's the meaning. Here should tell you to use the CRM to verify whether your method is correct. If you don't have the LCS, you can use the CRM. The measurement traceability, you can read it. If the calibration laboratories always need to trace to the SI unit, but not only for the calibration laboratory, for the calibration of balance, calibration of thermometer, calibration of the hydrometer, something like that. Because we also need to trace our measurement instruments to the SI unit, we need to prepare the calibration curve or the chemicals to see the response. Okay. There are two types of the SI unit, primary standards, the CRM, or the secondary standard. Okay. Just for your information. The traceability, the instruments may be like this. And your chemicals, the CRM, may be like this in this log. And one log will be traced back and with an broken chain to the SI unit assigned by the Metrology Institute in France. Okay. So to ensure this unbroken chain can be linked up without broken to your result, that means your result can be comparable with another laboratories. In China, we have the NMI, and also we need to recognize the name. If you purchase the CRM or the reference material, you need to trace back whether it is a valid supplier. Okay, supplier. This line gives you the information. In China, here is the address. Okay, BIPM. The BIPM is the organization and recognized in the People's Republic of China. The metrology lab is in where? Okay. This one is the matrix CRM certificate. How to read it? The matrix CRM, that means it's not only the chemicals. We have the matrix. For example, the phthalate. Phthalate is the chemicals that is used in the plastics as the additive, maybe to make it softer. Okay, softener. Now the matrix is the PVC. PVC is polyvinyl chloride. The PVC is just like water pipe in the toilet. In the toilet, it's very hard. However, if we add the phthalate into the PVC, it will make it very soft. You can make a plastic ball with very bouncy. You can bound with a very elastic surface because due to the phthalate is added. Okay, in this CRM, the certified value for this 1, 2, 3, 4, 5, we call it the certified value, is the concentration of those phthalates in this matrix. Okay, uncertainty plus or minus. Okay, in this uncertainties. Let's see, we have more information. Oh, sorry. This one. Okay, continue with the certificate in the report. We will have the catalog number. Catalog number, that is just like the information of PVC 001 is the phthalate in PVC matrix is the name, catalog number, the manufacturer's name. And the lot number will indicate this batch, okay? maybe the year is 2014, ship date, expiry date, you have maybe have 2 years for use. When you receive the certificate, you need to know where it is, when it is manufactured, and the expiry date. After that day, it cannot be used. If you purchase the same batch, should give the same result, okay? Indicated in the certificate. Storage condition, when you received, check out this very carefully. If the storage condition is changed, you cannot ensure the result. You give those results by this CRM. So we need to check this information. Instructions for use. For example, how you can use this for which test. For example, for this standard, if you want to do the method validation of this standard, yes, you purchase this chemical, this matrix CRM, okay? And of course, you also need to check the homogeneity, or we call it who manufacturer. Who is the manufacturer? The manufacturer should be accredited for the ISO 17025 and also with this ISO guide. This is the previous one, is for the CRM manufacturing organization accreditation. Okay. We go to another. This one is the another matrix CRM purchased from China. Purchased from China. In the Chinese organization, will give you this number, GBW. GBW, which it gives you the what is the chemicals. Maybe this chemical is another one. This one is another chemicals. The cadmium concentration, you should do, after you do the analysis, you will do this result. With the uncertainty, 0.22, right? K factor, you see the K factor? This one should be the expanded measurement uncertainty. Expanded and measurement uncertainty. The K equals to 2, that means the standard measurement uncertainty should be 0.22 divided by 2. This one, 3.4 divided by 2 is the standard uncertainty for chromium, for this chemical you purchase. This one is the matrix CRM because this one is the base body, the matrix in Chinese. Where it produce, this organization should be accredited as the CRM provider, so you have confidence to use. When you got the result, we have the calibration curve 0.12345, right? Normally, you will have the concentration calculated Y from the response, and then you see the deviation from your known concentration. The deviation 1%, 5.7%. You may define it with the slope. The coefficient is 0.99. Maybe the R square is 0.98 something. But you see, the lowest point have a large deviation. If you set it, the criteria is only plus or minus 10%. This point cannot be used. Okay. For your QC, just like your ICV, CCV, QC1, QC2, QC3, QC4 to monitor the instruments. The signal is deteriorating, becoming more smaller. The deviation in this one only 0.63%. This one around 10%. This one 5.7 something. In this more than 20%. You preset your criteria 10%, 20%. Out of your control is the QC4. If so, this QC4 will be failed. Okay. If this QC4 is the CCV, that means the samples injected in between this QC1 to QC2 can be reported. The 21 to 40 samples can be reported. Here, the 41 to 60 samples, because the CCV QC4 is failed, more than 20% tolerance, these samples the result cannot be released. Okay, we need to repeat to check out whether the problem is instrument, contamination, or another problems. Quality control gives you the summary. Method blank, always 20 samples. And the acceptance criteria, normally we will set up less than the method detection limit. Okay, detection limit, how to report. But it is also subject to change due to the HOCUS or other guidelines. Other guidelines that mean maybe the country guideline or the regional guideline, like this. For the spike samples, spike bank, also every 20 samples. For the GC or LC, generally, because the low concentration, the recovery should not be good. Or in a higher concentration, the recovery should be good. Okay, we will set up the recovery criteria like this. Okay, just to give you a general idea. The spike concentration, normally we will set up at the midpoint of the calibration curve. If I set up it very high near the top, the highest calibration point, it will be easy for the calibration of the for the analytical result will be out of the highest point. Okay, we need to measure our result within the calibration curve. So if you add too high concentration, if it is out of the calibration curve, you need to dilute the samples to repeat again. So normally the spike concentration is equal to the midpoint of the calibration curve only. Okay. When we calculate the spike sample recovery, you will have when you spike the sample and you know the concentration minus the original sample. If the original sample target analyte is 0, it will be easy. Okay. By your calculation, you know I add 100 ppm into it. If it is 0, if you get 100 ppm, 100% recovery, very, very good. If you lose something, 99%, if you get more, maybe due to the fluctuation of the measurement instrument, you will have the result more than 100%. Don't be afraid you get high concentration, more than 100%. Okay. Duplicate, we can set the criteria 10% or 20%. depending on the difficulty of the measurement analyte. For the volatile chemicals, maybe you can set 20% or even 30%. For aldehyde analysis, the gas analysis, the difference or the recovery calculation should be two results duplicate. The same sample, you have two results, average of two results, and the difference of two results should be less than 10% or 20%. It will be example for set up the duplicate criteria. The CRM, you should reference to the CRM criteria to set up the range or refer to this table. See which one is applicable. Also, we need to make the QC for the retention time or the LC retention time because it may shift. It may shift. Maybe due to the column, the GC column, you cut the column, the RT will be shift. If you cut too much, the separation will not be good. Or you use the LC because the aging of the LC column, more active site is blocked, the retention time will be shift. And you need to set up a criteria to maintain your result should be accurate. Here is the mass specification detection criteria. We will talk, maybe we have time, and just for your reference first. Here, you see the ratio, 100%, 30% is the 2-total ion ratio. So it falls into this category, 30%. The height, the ratio, you have the criteria of 25% of the tolerance, okay? It gives you the information. If the tolerance is out of the tolerance, that means you can define it is not the target analyte. In process control checks, for your general HOCUS, this is for summary. You need to have the blank calibration curve at its 3 point. Correlation coefficient, that means your R square. Don't rely only on this R square to judge whether your calibration curve is work or not. CCV, need to check. Traceability, use the CRM or the LCS. Method blank, duplicate, spike. Those are the in-process QC controls required by the HOCUS. Okay, give you the summary here. Here's the more example for the food analysis. You will have more information if you reference to SC supplemental criteria for 7. When you do some of the QC, we call it the external QC. We will talk about it in the last lecture. This is the external proficiency test. We will compare the result with others laboratories. Okay, we will talk about in the last lecture. That's the end of this lecture. Thank you. Let me see if you have questions. See whether it's the questions. Okay, for this rounding rule, you are rounding 5 digits. For example, this one, 5 digits, right? 1, 2, 3, 4, 5 digits. And due to the rule, If it's 445,000,000, the back is 0. Because we will read this one to be 4. This 4 is an even number. We will run in this way. This one is correct. It is a general rule in our standard I showed you before. Here. Oh, sorry. So it is an even number or did you hear? This for example. When we read the number of 5, okay, 5, we will read the odd number or even number in the front. If it is an even number, we will not round up. If it is the odd number, we will round up. Okay. Okay, back here. Could you kindly explain again in how CCV is prepared? When you're talking about this one, the CCV. The CCV is just like the ICV, but from another source. Another source, that means this one is from the brand B, okay? Brand B. You found another brand. This one is the brand B. You measure the weight of this chemical and dissolve in the solvent. This all is the brand A. Sorry, A. Sorry. All is come from the brand A. That means you have the chemicals from different manufacturer. If one manufacturer have prepared the chemical purity wrongly, you can check it by another brand. Okay. CV. Just like that. You purchase two, for example, nowadays, you purchase 2 R80 kits, right? For your test, if you unfortunately get positive. The suggestion is you try another R80 kit. If both are correct, you have the confidence it is correct positive. Something like that. You purchase brand A to prepare your calibration curve. And then if you use the same middle point, this one, for example, you use this one and put back. Here, because the Kelvin curve here and this chemical belong to the same family, belongs to the same family. You cannot check out any errors. You cannot check out any errors, but you choose another brand. You have a chance to use the brand B to verify those brand A is correct or not. Another question is that then what is the difference between the ICV and the CCV in terms of concentrations? Okay, I show others. I don't know whether you can read or not. What's the difference? The answer is they should have the same concentration at the midpoint of calibration curve. Normally, we will like this. The ICV, CCV should be prepared. Normally, people will use the midpoint of the calibration curve concentration. Okay. Do you have any other questions? You can type it. Let me see if I can answer it or not. If no, thank you for attending my lecture tonight. Good night.